So this is quadratic applications area, and if you read this word problem, you have a farmer that wants to use 80 meters of chicken wire to make a pen. All right, now he wants to use that wire, and one side of it is going to be the barn, and he's going to use the rest of the wire to form this pen right here. Now he wants to construct this pen in a way that will give him that this is the maximum area he can get out of 80 meters of chicken wire. Okay, so now for this, all right, the first thing we need to determine is we need to come up with some function. All right, we need to come up with some function that will give us something that we can work with. All right, so let's just say that this width is x. All right, so if this width is x, this is also going to be x. Okay, so now the trick is, how do I figure out what this length is going to be? All right, now think about it. If I have 80 meters of chicken wire, right, and if I subtract this distance and that distance right here, so 80 minus 2x is what I have left over of the chicken wire, and what I have left over is actually going to be the length of this rectangle. Okay, so again, if you look at, I'm just going to arbitrarily name this x, and if this is x, this is going to be x. So the perimeter of this, if you will, just this little three sides would be x plus this. Now add it up if you don't believe me, right? If I add x plus x, I get 2x. And if I add 2x plus 80 minus 2x, then I just get 80. Okay. So the function, if you remember, how do I figure out area? Okay, so area we all know is width times length or length times width, right? It doesn't matter which one you write first. So in this one, I'm going to call this function a of x. So this function can take this little distance. Okay. Now to figure that out, the width is going to be x, and the length is going to be 80 minus 2x. Alright, so that is going to be the function. Now, on this one, if I were to, I don't have to multiply it, and I would actually recommend that you didn't multiply it because you're going to create more work for yourself, but if I were to multiply this together, alright, I'm going to just write it over here briefly for you, I would get 80x minus 2x squared. Now notice that I have a negative 2x squared, so what that means is I have a parabola that's upside down. Okay. Now normally on area problems, you're going to have something that looks like this. Okay, so if you were to put this in your calculator, that's what it would look like. Now in this one, they're asking us for the domain and range, but really to do all of that, to find the domain and range, really I need to figure out what is the maximum area and what are the dimensions. Alright, so to figure out the domain, what I have to do is I have to figure out where this happens. Alright, now to figure that out, now remember that this right here, I'm going to call this area, so this is the area and this is the width. Alright, so if I plug in an x here, a width, that will give me the area. So just for the record, the maximum area will be the y coordinate at that point. Okay, now what is the area right here? The area is 0. Okay, so if I want to figure out what my domain of the function will be, what I have to figure out, so for domain, I have to figure out where this equation is equal to 0. So I'm going to write that up here. Now the reason I didn't want to multiply that is because this is already factored. Okay, so if this is already factored, I'm going to set each factor equal to 0, and then I'm going to solve. Alright, so there's one answer, and then the other answer, which I already knew that, right? This starts right here. And on this one I would have negative 2x is equal to negative 80. If I divide both sides by negative 2, I get x is equal to 40. Okay? So essentially what that means is if I make the sides 40, then I have no chicken wire left, so the area would be 0. Okay? Okay, so that's that for my domain. I'm going to say between 0 and 40. Okay? Now to figure out the range, I'm going to have to figure out what the maximum area enclosed is. Alright, so to do that, it's actually very simple. If you have this, especially for an area problem, the maximum is literally the vertex. Now because I already know the roots, right? We talked about this before. These are the roots 0 and 40. the vertex is literally right in between 0 and 40, which in this case, that would be 20. All right, so that width right here, if I plug in this width into this formula, that would give me my maximum area. Okay, so this is kind of a little bit strange here, but I'm going to basically figure out what the range is once I figure out what the maximum area is. Now, so the maximum dimensions, all right, I know the width, which is equal to x, would have to be 20. And the length would be equal to 80 minus 2, and instead of x, I'm going to plug in that 20. So that would be 80 minus 40, which is just 40. Okay? So this is the length, and that's my width. Okay, so going back to this one. So if you want to figure out what the maximum area is, I would just plug in 20 for x here and here. Okay, so again, to figure out the maximum area, basically figure out what is the middle between the two roots, and that's going to be where my maximum is going to be located. Once you figure out your x value, plug it in into the area formula, and then you should get the answer. So this is going to be 20, and then 80 minus 40, that's going to be 40. If you multiply 20 and 40, you get 800. In this case, that would be meters squared. Okay. So I guess if I'm putting dimensions, this for my length and width. So now, hopefully you can be able to figure out your range. Now, this part right here, this point is 20, 800. Okay? So therefore, my range is going to be 0 all the way to 800. All right, between here and here. Remember, I'm not going to write negative infinity or anything like that because this is a real problem and I cannot have negative area. Okay, so if I would go below this line, I would have a negative area. So that's it for that side. Right on the back, I have the same problem, all right, except for he decides to place the pen away from the farm. So now that way, this is just basically going to be some kind of pen, and I'm not going to rely on the barn to be part of the enclosement. Okay, and I still want to have the maximum area. Okay, now similarly like the other one, I still have 80 meters of chicken wire. I'm going to name this X and this X. Okay, now the amount of wire remaining, and I'm going to write over here wire remaining, is still going to be 80 minus 2x. Alright, so I have that much remaining. So remember, how do I know that? I have 80 meters total, and I'm subtracting this two widths. Okay, so that's what I have left. Now, I have to split that wire between those two sides. So to figure out the length, I would literally grab the remaining wire and then divide that by 2. Alright, which will give me 80 divided by 2 is 40. Negative 2x divided by 2 is x. So this right here is that, and that right there is also 40 minus x. Okay? Now, if that doesn't make a whole lot of sense, then at this side, if I add this plus this plus this plus this, I should get 80, and I do. Okay? So similarly like the other one, the function, right, to figure out the area of a rectangle, is going to be the width. Alright, so remember area, I'm actually putting the width first times the length. The width times the length, and in this case the length is 40 minus x. So again, similar like the other one, once I have that function, I know I know that that's what the problem is going to look like. Why? Because this is going to be a negative x squared if I were to distribute that x. So for all this enclosement problems, that's what it would look like. Okay. Now on this one, this is my area, this is my width. Okay. Now to figure out To figure out my domain, I have to figure out what this point is right here and this one. Well, I know this one's 0. Okay, now for the domain, remember what I said on the front page. On the domain, I have to set the area formula, which in this case is this, and I have to set that equal to 0. And if I solve each one, I get x is equal to 0, 40 minus x is equal to 0. So in this case, x is 40. Right, so x is also, in this problem, this roots are 0 and 40. Okay? Now, so my domain is going to be between 0 and 40. Now remember, it's asking me what is the maximum area. So just like the other one, right, the maximum area is going to be located up here. The y-coordinate of this point right here would be my maximum area. And that's located on my vertex. And that vertex is located right in between 0 and 40. Okay, so to figure out the maximum area, what I need to figure out is 20, all right? If the width is 20, that's going to give me my maximum area. So now that I know that, I'm going to plug in that 20 back into the function that I came up with here earlier. So I have 20, 40 minus 20, which is really just going to be 20 times 20, which is 400, okay? So this right here, 400, is my maximum area enclosed, which is actually also the y-coordinate of this vertex right here. Okay, so that's my maximum area. So now I can also have my range. My range is going to be between 0 and 400. All right. Now finally at the end, it says what dimensions will which will yield the maximum. What are the dimensions which will yield the maximum area? Well, I already have the width. Right, the width, which was x, is equal to 20. Now to figure out my length, remember my length was up here, 40 minus x. So I'm going to just plug in a 20 for x. So in this case, notice that my length and my width are actually the same. So what that really means is that the maximum area enclosed is just going to be a square. Okay, make sure if you have some questions over this, make sure to ask us when you see us.